All right, folks, are you ready for level 2 partial fraction decomposition? Well, if you were good at the level 1s, or if you eventually got good at the level 1s, or level 1 partial fraction decompositions, you should be okay with this one, okay? What we're now going to do is we're going to introduce x into the numerator in the rational expression. So let's say that we have, x over x squared plus 6x plus 8, okay? So what's our first step going to be? Right, we're going to factor the denominator, right? Okay, so we're going to have x over two numbers that multiply to 8 but add up to 6 are positive 4, positive 2. So we're going to have x plus 4, x plus 2, right? And so now our next step, because we have two factors, we're going to have two fractions. We're going to have a over x plus 4 plus b over x plus 2, right? And now the next step is to bring down this numerator piece here. This x is equal to, we're going to multiply the a times the x plus 2, right? So that's going to give us a times x plus 2 plus the b times the x plus 4, right? So b times x plus 4. Now you can pause this video at any time and work ahead if you want to see if you understand. If you're able to work ahead by one step and then see me do it and it's the same, you are really getting it. But if you stop one step at a time and you get something wrong, you didn't go too far. Okay? Don't ride along. This is not a vehicle where you're riding along. This is a vehicle where you're driving and I'm helping you along as you drive. Okay? This is you doing the work, you learning, and I'm just validating what you're doing. So now we're going to distribute the a, right? So we got x equals ax plus 2a plus b times x, b times 4, bx plus 4b. Okay? And now I'm going to rearrange it and put the ax and the bx together. So x is equal to ax plus bx plus 2a plus 4b, right? And now I'm going to factor out, like I've done every single time, I'm going to factor the x out and I'm going to make it a plus b times x. Okay, this is equal to x. And now, I'm going to stop just for a second. Now, we have an x now. Last time we didn't have x. The last couple examples we didn't have an x. So we just said that a plus b is equal to 0. Well, now a plus b is going to be equal to the coefficient of x. And what's in front of this x? A 1, right? So a plus b must be 1 because this is 1x equals 1x, right? So a plus b must be equal to 1. Now bring down the plus 2a plus 4b. Now, this is interesting. Last time we had a constant here. This time we don't have a constant. So this 2a plus 4b is representing the constant over here. What is our constant, though? If there is no constant, meaning a number without a letter, right, it must be 0. So therefore, 2a plus 4b must be equal to 0. So we're going to write that down, that 2a plus 4b must be equal to 0. And now we can find out what a and b is, or are, by solving this as a system of equations. I like elimination. A lot of other people do too. You could use substitution. You could subtract b from both sides if you wanted to. Okay, and you'd have that a is equal to 1 minus b, and then you could put 1 minus b in here. Well, let's go ahead and do that. 2 times 1 minus b plus 4b is equal to 0. Then 2 times 1 is 2. 2 times negative b is minus 2b plus 4b. 2b or not 2b. Sorry. All right, equals 0. Negative 2b plus 4b is 2 plus 2b equals 0. Subtract 2 from both sides. 2b equals negative 2. Divide by 2. Divide by 2. b is equal to negative 1. Then put negative 1 up here. Remember we said that a is equal to 1 minus b. So that's 1 minus negative 1, which equals 2. So a is 2. b is negative 1. That's by substitution. But you might say, Mr. Ryan, why'd you change it up? I was doing a lot better when you left it as elimination. Can we please go back to doing the elimination? Yes, we can go back to doing elimination. So we know that a plus b is equal to 1. We know that 2a plus 4b is equal to 0 because there aren't any constants over here. So let's make the let's cancel the 4b, shall we? So we'll multiply by negative 4 up here. We'll multiply all this by negative 4. Negative 4a, negative 4 times b is negative 4b equals negative 4 times 1 is negative 4. Now eliminate the b's because we got a positive 4 and a negative 4. And now 2a minus 4a is negative 2a equals 0 plus negative 4 is negative 4. Divide by negative 2 on both sides. And you get a is equal to 2, just like we did before. Go back up here to a plus b is equal to 1. Put a 2 in for a. 2 plus b is equal to 1. Subtract 2 from both sides, and b is equal to negative 1. So now we have our a, we have our b, and our final answer is 2, because a is 2, over x plus 4. Negative 1 for b, so I'll put minus 1 over x plus 2. And this is our partial fraction decomposition. Now, if you are not understanding this, it is critical that you watch the video again. If you're not getting it the first time, you got to watch the video again. Your brain sees patterns. Your brain understands when it sees the same pattern over and over and over and over and over again. Some of you are getting the fact that I keep doing this system of equations, and that pattern is making its way into your head. We're going to do one more example of the level 2. One more example of the level 2. Then we can move on to level 3 and be victorious. All right, let's do this one. Let's say we have 7x plus 2. Now we have an x and a constant. I don't know if you've noticed that yet. Okay, that first couple we had only constants. The one we just did, we only had an x. Now we have a constant and an x. Okay, so that's going to make things interesting. Over x squared minus x minus 30. Okay? Step 1, you remember? Factor the denominator. So we'll have 7x plus 2 over. Two numbers that multiply to negative 30 but add up to negative 1 are negative 6 and positive 5. So we're going to have x minus 6 times x plus 5. Right? So that's going to become now two separate fractions, all on their own. One has an x minus 6, one has an x plus 5, one of them gets an a, one of them gets a b. Okay? Next step, we're going to shortcut all the common denominator stuff and just carry straight down, carry the 7x plus 2 down, equals a is going to be multiplied by the other denominator, so a times x plus 5, plus the b is going to be multiplied by the other denominator, b times x minus 6. Now we're going to distribute. So 7x plus 2 is equal to ax plus 5a. Then we're going to distribute here, plus bx minus 6b. Okay. Now, again, we're going to put these two next to each other. The a and the b with the x, we want to put them next to each other. So we'll have 7x plus 2 is equal to ax plus bx. We do this every time, the same thing, every single time. The more we do it over and over, over and over, over and over, the better our brain will remember it. And it doesn't matter if it's boring. Your brain learns through boring. When you keep doing the same thing over and over, same boring pattern over and over, your brain starts to understand, and it reminds you later of a pattern that you gave to it. Okay? So we got the ax plus the bx plus 5a minus 6b, right? Factor out the a plus b, so 7x plus 2 equals a plus b x. Now, I'm going to pause for just a second again. Notice, We have a plus b times x. Over here we now have an x. And what's in front of the x? A 7. What's in front of the x over here? A plus b. That must mean that a plus b is equal to 7. So we're going to write that over here. A plus b is equal to 7. Now, plus, just carry the stuff down, plus 5a minus 6b. This is the constant, and over here our constant is 2, and therefore 5a minus 6b must be equal to 2. So we're going to write 5a minus 6b is equal to 2. We now have another system of equations. You have to decide, am I going to cancel the 5 or the negative 6? Let's cancel the negative 6 because I only have to put a positive number in here. So if this is a negative 6, I need a positive 6 in front of the b. So I'm going to multiply by positive 6. Multiply by positive 6. 6 times a is 6a. 6 times b is positive 6b. 6 times 7 is 42. Now add. Negative 6b plus 6b, that eliminates. 5a plus 6a, that's 11a, equals 2 plus 42 is 44. Divide by 11 on both sides. And what is a equal to? A nice whole number, 4. So a is equal to 4. Well, if a is equal to 4 and a plus b equals 7, a plus b equals 7, then what is b equal to? B must be equal to 3 because 4 plus 3 is 7. So we have our numbers. A is 4, b is 3. So our final answer is, I'll put it over here, 4 over x minus 6 plus 3 over x plus 5. This is the partial fraction decomposition of this. Now, here's the cool thing. Remember when you first started learning, just a few days ago, how to add rational expressions? In those questions, this was a question I would give to you, and the answer would be this. But today, this is the question, and this is the answer. See, you're just moving backwards. You're breaking apart the addition of rational expressions.